Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question paper of mechanics, and the paper code of this question paper is 9709/43 for the session May June 25. Let's start with the solution to question number 1. Question number 1 says two particles P and Q of masses 0.1 kg and 0.3 kg respectively are at rest on a smooth horizontal plane. P is projected directly towards Q with speed 4 meter per second. At the same instant, Q is projected directly towards P with speed u meter per second. After P and Q collide, P moves with speed 2 meter per second and Q moves with speed 4 meter per second. Find the two possible values of U. Since the question is based on the velocity before and after collision, so we will have to apply the concept of the conservation of momentum. So let's write the formula of equation of the momentum. MA, not AMP plus UP plus MQ, mass of particle Q, into initial velocity of Q is equal to mass of particle P into final velocity of P plus mass of particle Q into final velocity of particle Q. So what is the mass of the particle P? Mass of particle P is 0.1, whereas the mass of particle Q is 0.3. So it is an initial velocity for particle P is 4 meter per second and particle Q is u meter per second. 4 u meter per second and u meter per second. So let us write the values. Mass is 0.1. Sorry, here it should be into initial velocity of particle P is 4u plus. Now look at this. Q was projected directly towards P. Look at this. Q was projected towards P. That means the direction of both of the particles were opposite to each other. So the symbol in between them will be negative. Mass is 0.3 and initial velocity is u, equal to mass of particle A is 0.1 and final velocity was 2. For particle Q, mass is 0.3 and final velocity was 4. Then if we simplify this, it is going to be 4u and 3u. That means if we subtract, it is going to be 0.1u is equal to, on the right side, if we do addition, it is going to be 1.4. 1.4. Hence our u is equal to 14 meter per second. Meter per second needs not to be written, dimension is already given. U is 14. So this is one of the value. They have told us to both the values. Then if the particles, here you can mention that when both particles move to the when both particles move to the same direction, to the same direction after collision. After collision. So this is the velocity of value of u when both the particles were moving to the same direction. That's why here the symbol is same in front of both of them. The velocity after collision. Well, now the second possible case, we will write when particles move, when particles when particles opposite direction. Okay, then for only here the change is, it's all the same, there will be change in symbol, I mean direction. That's why let us copy the previous part. It is MPUP. Okay, MPUP plus MP, mass of particle q into initial velocity of particle q is equal to mass of particle p into final velocity of particle p, plus, as there, look at this here, this is the clue word, the direction is opposite to each other. So instead of positive symbol, okay, let us change the symbol in the next step. Okay, mass of particle q into final velocity, I mean velocity after collision of particle p. So if we substitute, it is going to be zero point 0.1 into 4u plus, sorry, not plus, they were moving to each other, minus 0.3u equal to 0.1 into 2. Now look at this, as the direction is different, so here we will have to make a change. Look at this, when the both the particles collide with each other, let us go back to the question. Look at this, the mass of particle p is less than mass of particle q. So if they change the direction after collision, then p will go backward. Okay, that's why the symbol of p will be negative. Remember, here the symbol of p is going to be negative because p will go backward. Plus mq, mass of particle q is zero point 0.3, and final velocity of particle, it was q, was 4. Okay, then let me write somewhere else beside this. I can write just on the left side, or what is it going to be? 4u minus 0, left side is left side will remain unchanged, 0.1u. On the right side, what is it going to be? It is 2, and if we subtract 2 from 12, it is actually 10, and 10 means 1.0, so it is 1. Okay, now our e is going to be, hence our u is going to be actually 10. So this is the second possible answer when p was moving backward after collision. Let's see what the next question say. The next question says, find the largest possible loss of kinetic energy in the collision. So here, as loss of kinetic energy is change in kinetic energy actually. Now, which one is the largest one? For largest one, as there are two initial velocity, the components of change in Ke or kinetic energy are nothing but difference between the final and initial velocities. So in this case, as one of the initial velocity is larger, so we will have to apply that one. For larger initial velocity, loss of energy is greater. Let me write this. So keeping this concept in mind, that larger initial velocity, loss of energy will also be larger. Then we will find u is, we are going to find loss of energy. U is equal to 14 when, because larger initial velocity was 14, when loss of kinetic energy, or only energy, whatever you write, kinetic energy, kinetic energy equal to kinetic energy equal to you know the kinetic energy, the formula for kinetic energy, and as this is loss, so we will use negative symbol. Change in kinetic energy of particle P minus change in kinetic energy of particle Q. And the formula for change in kinetic energy is nothing but half mv square minus half mv square of, this is for Q and this is for P. Now let us substitute the values. Mass of particle A was 0.1 and initial velocity of particle P was u was, let us see, u was 4. So initial velocity of, not initial, actually this is the difference between final and initial velocities. So let us see what was the final velocity of particle P. Look at this, final velocity of particle P was 2. This is the final velocity, and initial velocity was this 4u. So 4u means 4 14s are 56. So 2 square minus 56 square. 2 square minus 56 squared minus half of mass of particle Q is 0.3, and the final velocity of particle Q was, what was the final velocity of particle Q? It was 4. So 4 square, remember you will have to subtract from final velocity, square of the final velocity minus square of the initial velocity. Initial velocity of particle Q was only u we have already obtained, u is 14. So 14 square, 14 square. Then if we simplify this, let me write just over here on the left side. Yes, on the left side, or can I write on the right side? No, right side there is no space at all. So for the, it is going to be what? Since the negative term is greater, so it is going to be positive or equal to, it is going to be, denominator is 2 for the first case and numerator is going to be 313.2. 313.2 plus, so is the second part, plus denominator is 2, let us write 2, and numerator is going to be 196 minus 16, so 180. 180 into zero point 0.3. So 0.3 into 180 is 54. 54. Now finally we will get this total loss of energy is 183.6 joule. So this is what the final answer, the loss of total energy. Well, let's move on to the next question. The immediate next question says, it says, yes, a van of mass 4,500 kg is towing a trailer of mass 350 kg along a straight horizontal road. The van and the trailer are connected by a light rigid tow bar which is parallel to the road. There are resistance forces of X Newton on the van and 120 Newton on the trailer. The driving force produced by the van's engine is 2500 Newton. The tension in the tow bar is T Newton and the acceleration of the van is 0.4 meter per second square. Find the value of X and the value of T. Well, as there are two objects connected with each other, we will have to apply the concept of the motion law of Newton. Then for first of all, let us resolve the forces of trailer. So for trailer, trailer, for trailer, for trailer. Okay, and as it is moving horizontally on road. Okay, okay, straight horizontal road. So direction is this. Then the concept we are applying the driving force minus resistance to motion is equal to mass into acceleration. Okay. So driving force for trailer is nothing but the tension, and the resistance to motion, resistance forces of 120 newton on the trailer. Trailer's resistance, constant resistance force is 120 newton. So 120, and there is no other forces acting on the trailer, equal to mass of trailer is 350, and acceleration of each of them is zero point 0.4 meter per second square. So our tension is going to be let it be the final step. So it will be hence 350. This is going to be 140. 140 plus 120 is equal to 260. So T is equal to 260, first of the answers. Okay, then the next one. For the next one, we will resolve the forces for the van. For van. For van. And direction is same. So we can show the direction as for van, the same concept. Driving force minus resistance force is equal to mass into acceleration. And driving force of the van is given as 2500. So 2500, resistance to motion is x, minus tension is equal to mass of the van is 4500, and acceleration is 0.4 meter per second square. So what is it going to be? Our 2500 minus x minus tension, we have just obtained. Tension was 440, sorry, 260. Let us see how much was the tension. Tension was 260. Okay, so we can use this information. 260, 260 is equal to, if we multiply this, it is going to be 1800. Hence our x is going to be, simply we can write 2500, 260 minus 260 minus 1800. So it is going to be 440. 440 is the force acting along x, or value of x is 440 newton. Then let's move on to the question number 3. Okay, 3 is on the next page. It's a velocity time diagram, velocity time graph. So from here, the question says, yes, if I show whole of the question, the question says the diagram shows a velocity time graph which models the motion of a particle. The graph consists of 3 straight line segments. The velocity of the particle at time t second after passing a fixed point O is v meter per second. The particle leaves O with a velocity of 5 meter per second and accelerates at 0.75 meter per second square for 20 seconds. The particle then decelerates for the next 30 seconds. At t is equal to 40, the velocity of the particle is 0. After t equal to 40, the particle starts to travel back to O, coming to rest at O at time t second. So here the concept is actually simple concept. I mean, the overall we will have to know that the velocity, I mean the distance traveled, the distance of the part above, distance travel Distance traveled in first 40 seconds must be equal to the distance traveled in the rest of the time, because it was actually came back to the same position. It went there and again it came back to the same position. So actually the distance, the concept is the total distance traveled in first 40 seconds must be equal to the total distance traveled in the rest of the time. Okay, stepwise we are going to solve this. First of all, we should know how much was the maximum velocity when it was moving onward. So for that, we will have to write for 0 until time was 20 second. At 20 second, the particle was moving at the highest speed. So let us find the speed at that moment. V equal to u plus at. And how much is our velocity is to be obtained? Initial velocity was 5. So 5 plus acceleration is given here. Acceleration is 0.75. Look at this, acceleration was 0.75. So we will just multiply by 0.75 and time was 20 seconds. Hence our velocity, the maximum velocity is 20 plus, so 15 plus 5 means 20. 20 meter per second, 20 meter per second. That means here it is 20. It is 20. Well, so this is one of the part. Then we will have to find how much was the acceleration. That means this one we should know the acceleration of this this part. This part and the upper part are same. So we will write here for, let me change the ink. For the next phase is from 20 until 40. 20 until 40 seconds. The same formula, Subert formula, we are going to apply. V is equal to 0. Velocity is 0. Look at this. If I show you from the graph, look, when the time was 40 second, at 40th second, it velocity was 0 at this point. At this point, velocity was 0. So V is equal to U plus 80. U plus 80 is equal to 0. Hence our initial velocity was, it started from 20. So 20 plus acceleration is to be obtained and time is from 40. If we subtract 20, it is actually 20 is equal to 0. Hence our A is going to be -1. Let us write, hence our A is 20 divided by 20 means 1, but as it is negative, so -1 meter per second. As we have already obtained the acceleration at the second stage, then we will find how much is this velocity, because this at this, how much is this velocity, it should be obtained. So we will have to write for 40 until 50. For, just over here, for 40 until, or I think I can write not over there, for 40 until 50 second, our V is equal to the same concept. So what formula, V is equal to U plus AT. Okay, so our V is going to be, initial velocity U was 0 and acceleration was negative. Already we have obtained, it is -1 and T is 10 seconds. Hence our velocity is -10. 10 meter per second, for which phase? From the time from 40 to 50 seconds. Well, now they have told us actually to find this t. Okay, how much is this? This t is to be obtained. Already we have explained that it is nothing but the concept of the distance traveled in the first 40 seconds must be equal to the distance traveled in the rest of the time. So we will write this. Let me find a place. Yes, we can write over here. Distance traveled, distance. So what is the distance traveled in t minus 40 seconds? T minus 40 seconds, it is a triangle. Look at this. The triangle lying below the x-axis. So area of triangle is, we know the distance means the area of the traveled distance. So half of this triangle base is t minus 40, t minus 40, t minus 40 is the base, and height is, we have already found here, height was 10. This is 10, negative 10. So here negative 10, it is negative 10. Okay. So it is negative 10. As we are writing height, height can never be negative. So into 10 equal to, now in the upper part, I think in the first 40 seconds, look at this first portion. This is a trapezium. This part is a trapezium. So area of trapezium is half of the sum of the parallel sides, which is 20 plus 5. 20 plus 5 into distance between the parallel side is 20 into 20. This is for the first part, trapezium, for first 20 seconds. But the next part, it is a triangle. This part is a triangle. Okay. The second part is a triangle. So for triangle, the formula is half of, let me write the formula of plus half of base is how much? Base is 20 to 40, that means 20, and height has already been obtained. We have obtained the height was also 20. So let us write 20, 20. Hence, or if we calculate this, this is going to be 5. Every quantity is containing half, so let this half be dissolved. After that, it is going to be 10t minus 400. 10t minus 400. 10t minus 400. And the right side is going to be, let's see, it is 25 into 200. So 500 plus 400, that is 900. 900. Well, so our t is going to be 10t or 10t. Let me write over here. Or 10t is equal to 10t. 10t is equal to 900 plus 400. It's 1300. 1300. Hence our t is going to be what? T is going to be 130. 130 second. That is what our final answer. Look at this. Here, there should be. That's all about the solution to the first part of this question. Then let's move on to the next question. The immediate next question says, find the acceleration of the particle when t is equal to 50 to t is equal to t. And t means actually uppercase t, which is already we have obtained, which is 130. So the acceleration between 50 until 130, that is 50 until 130 is, if I erase the unnecessary parts from the figure. So acceleration from the time, that means acceleration is, they have told us to find this acceleration. Okay. And the time, final time when the particle came back to the origin was 130. It is 130. So let us start applying the same concept we are going to apply as we did in previous two cases, which is our v is equal to u plus at. Okay, so let us write v equal to u plus at. Hence our u was what? Already we have applied this, u was negative 10. Look at this here, this is negative 10. So and time is 50 minus how much? 130, so it is 80. So let us write negative 10 plus acceleration into t was 80, because uh, uppercase t was 130, so 130 minus 50 means 80. Hence our a is going to be, or our a is going to be, what will a be? It is 10 over negative 10 over negative 10 over 80, negative 10 over 80, not negative. Look at this, if 10 is transposed to the other side, it is no more negative, it is positive actually. That means our acceleration a is equal to, if we divide 1 by 8, it is 0.125 meter per second squared. So that is what our answer to the final part of this question is. That's all about the whole of this solution, and let me show you whole of the solution at a glance. Then we are moving on to the immediate next question, question number 3. The next question is question number 4. Let's start reading question number 4, which says that 3 blocks P, Q, and R of masses 25 kg, 20 kg, and m kg respectively are held in equilibrium by 3 light inextensible strings OP, OQ, and OR. The strings OP and OR both pass over small fixed smooth pulleys A and B respectively, with P and R hanging vertically below the pulleys. The block Q hangs vertically below the point O. The angle between OA and the vertical is 30 degree, and the angle BOQ is equal to alpha degree. Find the value of M and the value of alpha. So let's start solving this question. Before we start writing the solution, actually, this is as equilibrium, forces and equilibrium, so we'll have to resolve the forces vertically and horizontally. Before moving on to that, first of all, let me complete the diagram using triangle. So this is our figure. Okay, now first of all, we will have to resolve the forces horizontally. If we do so, then let me write horizontal forces. Okay, so our direction is horizontally. Driving force, the concept of the motion law of Newton, driving force minus resistance to motion is equal to mass into acceleration. So for driving force, look at this, this is positive direction. Okay, this is positive direction, and that is negative direction. Okay, this is negative direction. So for positive direction, if we use this alpha, it is going to be mr sine alpha, mg. So mg sine alpha. Here look at this, the mass of this, if you talk about this one, this hypotenuse. Okay, hypotenuse is actually how much? Mass into acceleration. So this hypotenuse is mr. Okay, mr, let me write this r as tiny as possible, mg. Then as we are talking about this in term of the triangle, this is sine. So sine alpha minus the negative force. Negative force is negative direction is this one. So it is going to be, and what is this the string? This is hypotenuse. In this one, our mass is mass of particle P. Okay, mass of particle P, and this angle is horizontal. I mean, we are finding for horizontal axis, so it is mp cos alpha. mp, then g, sorry, g should not be ignored. G cos alpha. Cos alpha is equal to, as the system is in equilibrium, so it is 0. Resultant force is 0. After that, we will have to apply the values. How much is the mass of particle r, which is acceleration due to gravity is 10, so it is 10m. 10m, and sine alpha minus, so mass of particle P is 25, so it is going to 25 into 10, 25 into 10, and cos alpha. Okay, so sorry, not cos alpha, it is 60 degree. Here we made a great mistake. It should be 60 degree, not alpha. Here angle is 60 degree, and don't get confused to look at this. If this angle is, if this is here, look at this, if upper part is 30, so definitely this lower angle is 60. So we will have to write cos 60 degree. Cos 60 degree, 60 degree, and cos 60 degree is equal to actually 2, means zero point 0.5. Okay, this is 0.5. 0.5 is equal to 0. Then if we simplify, we will find that 10m sine alpha is equal to 10m sine alpha is equal to 250. Half of 250 is actually 125. So it is 125. Then if we isolate sine alpha, it is going to be, or sine alpha is equal to, let me write on the left side, or it is going to be sine alpha is equal to, sine alpha is equal to 125 over 10m, and both of them are divisible by 5, so it is 25 over 25 over 10m. 25 over, sorry, 2m. 2m is our one of the equations. We'll have to form two simultaneous equation because two values are missing. This is equation number 1. Okay, then we will resolve the forces vertically. If we resolve the forces vertically, what will it be? Let us show this. Look at this, the same concept we are going to apply. Driving force minus resistance force is equal to mass into acceleration is 0, because system is in equilibrium. So driving vertically, if we use vertically for the first triangle, here upward force is only having the this triangle. This triangle is having upward force, so it is going to be mpg. So it is going to be m mass of particle p, actually mass of particle p, g sine 60 degree, sine 60 degree, minus, what is downward triangle is this one is downward. Okay, we have calculated the upper one from here, this one. Okay, then downward is this, it is going to be minus MQG sine 90 degree. It is about, if we talk about this one, we cannot ignore this one also, because this is also acting downward. MQG sine 90 degree, here angle is 90 degree, sine 90 degree minus 10 mr cos alpha. For this one it will be m cos alpha. So minus m, the name of this particle is r g cos alpha is equal to, right side is 0. So if we substitute the values, mass of particle P is actually 250 into 10, 250, acceleration due to gravity is 10, and sine 60 is square root over 3 over 2. So we can write it as square root over 3 over 2 minus, here it is going to be, mass of particle q is 20 and acceleration is 10, sine 90 is 1, so it is simply 200. 200, let me write here 200 minus mass of particle r. Mass of particle r is m and acceleration due to gravity is 10, so 10 cos alpha equal to 0, equal to 0. Then what is it going to be? If we isolate cos, cos will be, or cos alpha is equal to, cos alpha is equal to negative 10m, negative 10m, and numerator is going to be, this is 520, 125 square root over 3 minus square root over 3, it is not going to be minus, let me zoom it out. No, there should not be any negative symbol here, because we have dissolved all of the symbols. Hence, this is 10m. Okay, 125 root over 3 minus 200 over 10m. This is equation number 2. Okay, now we will divide equation number 1 by equation number 2, so that we can find 10 alpha. Okay, as I don't have sufficient space to write over here, let me have a page. Okay, so we will write from equation 1 divided by equation 2. What was our equation 1? Our equation 1 was sine theta. So let us write here sine theta over cos theta. Sine theta over sine alpha over cos alpha is equal to equation 1 over 1. Let us go back to this page. Here equation 1 was what? It is below this. Over here 25 over 2m. 25 over 2m. So let us write equation 1 was 25 over 2m, and equation 2 was, if we go back to the previous page, equation 2 was 125 root over 3 minus 200. That is, by simplifying this, we can write here by 5. If we divide all of them, it is going to be 25 minus 4, 25 root over 3 minus 40 over 2m. So let us copy this. It is going to be 25 root over 3, 25 root over 3 minus 40 over 2m. Now look at this, both the 2m's are divisors, so they can dissolve each other, and on the left side it is going to be 10 alpha. Okay, tan alpha is equal to 25 over numerator is 25 and denominator is going to be 25 root over 3 minus 40. Hence our alpha is going to be tan inverse of, alpha is equal to tan inverse of uh, it is going to be 25 over 2 square root over 3, not 2 square root over 3, sorry, it was a slip of pen. It should be 25. So 25 root over 3 minus 40. If we use our calculator, our a is going to be, I mean alpha, hence our alpha is going to be tan inverse of 25 root over 3 minus 40, which is 82.5 degree, 82.5 degree, which is one of the answers. So we have obtained alpha. Okay, now we require to find m. Okay, for m any of the equations can be taken. Our, if we take the second equation, look at this equation 2. Hence let us write, hence this is our second equation. Okay, this one is our second equation, cos alpha equal to, so alpha is equal to, I mean if we want to isolate, hence cos alpha is equal to cos alpha is equal to 25 root over 3, 25 root over 3, my stylus works very slowly, minus 40 over 25, 20, sorry, over 2m, over 2m. Then if we isolate m is going to be 25 square root over 3 minus 40, then 2 cos alpha, 2 cos, and alpha is 82.5. Already we have obtained that 82.5, 82.5 degree, 82.5 degree. Then using our calculator we find that m is equal to 25 root over 3 minus 40 over 2 cos 82.5, which is 12.6. If we round it up to three significant figures, it is 12.6 kgs. Kg is not necessary to be written. So these are the two of the values. One is 82.5 acceleration, I mean angle, and mass of particle r is 12.6 kg, 12.6 kg. So that's all about the solution to the whole of this. If I show you whole of this, it started from here, though this is very untidy because the display is very small, to cover whole of this. And the next part is, so the final part of this solution is over here. Let's move on to the next question. Question number 5 is on the next page, page number 7. Okay, so the question number 5 says, a van of mass 2500 kg traveling at speed v meter per second experiences a resistance force of k v square newton. The constant power of the van's engine is 62.5 kilowatt. The steady speed that the van could maintain when moving along a straight horizontal road is 50 meter per second. Show that k equal to zero point 0.5 and find the acceleration of the van when its speed is 25 meter per second on this straight horizontal road. So road is our straight horizontal road. Okay, so let's start applying the concept of the motion law of Newton. So driving force minus resistance force is equal to mass into acceleration. What is the, how much is the driving force? So you know driving force is equal to P over V, power over velocity, minus resistance to motion is already given, which is kV square. Okay, so kV square, and as it is traveling across horizontal road, so weight is already resolved equal to 0, because we are trying to find the constant speed, steady speed. Look at this. Or power is 62.5 kilowatts, so 62,500 over velocity is 50. Velocity is 50, then v square means 50 square, 50 square v k, sorry, 50 square k is equal to 0. Hence our k is going to be, if we dissolve one of the zeros, so our k is going to be um, 50, it is 2500. Okay, so 2500 minus 6250, which is 121,250 over 50 square, 100 means 50 square means 2500. Hence our k is equal to 0.5. K is equal to 0.5. They have told us to show, and we have shown. Then the next question says, let us see what the next question says. There is no question on this page, that's all. So let's move on to the, only this one is, there is one more part left to be solved. They have told us to find the acceleration also. So for acceleration we are going to apply the same concept. The concept is, it is still moving in the horizontal direction, so driving force minus resistance to motion is equal to mass into acceleration. Okay, as there is acceleration, so driving force is equal to P over V minus resistance to motion is 0.5 V square. 0.5 V square is equal to mass into acceleration. Mass of the car was 2500 acceleration. Okay, now our power is 62500 and velocity is 25. They have told us to find, look at this, when the velocity is 25, speed is 25, so we are going to apply this value. It is 25 minus 0.5 into 25 square. 25 square is equal to 2500 A. Okay, now what is our A going to be? Here we can dissolve this. It is going to be 25, 25. So 2500, 2500. And here it is 625. Half of 625 is 325. No, not 325, it is 312.5. Then on the right side, 2500 A. And if we isolate our A is going to be from 2500, it is 2500 minus 312, so it is going to be, what is it going to be if we do subtraction? It is going to be 2187.5, 2187.5 over 2500. Hence our acceleration is going to be, if we divide this by 2500, then it is going to be 0.875, 0.875 meter per second square. So this is the acceleration. The car is maintaining while the speed was 25 meter per second. Let me show whole of this solution. Yes, this is whole of the solution. Then question number B. For question number B, we are moving on to page number 8. For B, system is in a different state. The van begins to ascend a hill inclined at an angle theta degree to the horizontal. The van travels along a line of greatest slope of the hill. The speed of the van at the start of the hill is 20 meter per second and its acceleration is 5 meter per second square. Later, on the same hill, the speed of the van is 30 meter per second and its acceleration is a meter per second square. The power of the van's engine remains at 62.5 kilowatt and the resistance force remains at zero point 0.5 v square newton. So on the same hill, actually there are two different velocities as well as two different accelerations. That's why we'll have to form two equations. And before that, if I draw the figure of this, the van is, let me draw the figure. Yes, this may be the figure. So we will have to, this is the diagram. Then applying these information, let us apply the concept of the motion law of Newton. So we will write when the velocity was 30, okay, v equal to 30, v equal to, because there were two different velocities on the same hill, v equal to 30 when as it is ascending, direction is leaning. So driving force minus resistance to motion is equal to mass into acceleration. So what is the driving force here? If we look, driving force is actually P over V minus our resistance to motion is given kv square, we haven't forgotten, so it is 0.5 v square minus, now weight is also causing resistance to motion, minus mg sine theta is equal to mass into acceleration. Mass of the car is 2500 and acceleration is to be obtained. Acceleration is missing. Well, power is same, it was 62500 over velocity is 30 minus zero point 0.5 velocity is 30 square into 30 square minus mass of the particle, mass of the car is 2500. So if we multiply by gravitational energy, I mean acceleration, then it is 25,000 and sine theta is equal to 2500 a 2500 a. Then if we simplify more, then we will get this is not absolutely divisible. So what we can do is only by 3 we can, 1 0 can be dissolved, so it is going to be 6250 over 3 minus, this is 900 into zero point 0.5, that is 450 minus 25,000 sine theta is equal to 2500 a 2500 into acceleration. Now if we multiply every quantity by 3, it is going to be 6250 minus 345 135, so 1350 minus 25, that is 75,000 sine alpha, and if we multiply by 3, it is 7500 alpha. Now if we isolate sine alpha, what is it going to be? Or from 6 to 50, if we subtract 13, it is going to be 1400. 1400 minus 7500. I think we can cut it short. 4900 minus 7500 alpha over negative 75, negative 75, 75,000. 75,000 equal to sine alpha, equal to sine alpha. Simplifying more, we can write sine alpha is equal to, or sine alpha is equal to, sine alpha is equal to, dissolving the symbols and two zeros can go away, so it is 75 minus 75a, 75a minus 49 over 750, 750. We may leave this as equation number 1. Sorry, we made a disorder to the symbols. It should not be, this symbol should not be negative. Okay, this is positive. So simply it will remain as it is. That means sin theta is equal to 49 minus 75a over 750. Well, as we have resolved the forces horizontally, now we are of forces when the velocity was 30. Now there is another velocity mentioned on the same hill. So we will write when velocity, let me write, velocity is 20 when the direction is still same, because the van is moving on the same hill still. So driving force minus resistance force is equal to mass into acceleration. Okay, it's all the same. P over V minus resistance to motion is 0.5 V square equal to mass into acceleration. Mass is 2500. And about acceleration, there is something to be noted. Look, here when the velocity was 30, acceleration was a. But when velocity was 20, look at this. When velocity was 20, but acceleration was 5 meter per second square. So we should not write only a, it is 5a. 5a meter per second square. And power is as usual 6250 over velocity is 20 minus zero point 0.5, as velocity is 20, it is going to be 400. Okay, and 25 times 5 is 1 to 500, 12500 alpha, I mean acceleration. Or if we divide it, it is going to be 3125, 3125 minus, oh sorry, we forgot to write, to calculate the weight. Look at this, weight has been ignored, which is absolutely wrong. So let us write this weight also over here. Before writing right side, it is minus, minus, minus mg sine theta. Mg sine theta is equal to, right side is mass is 2500 and it is 5a. So in the immediate next step, it is going to be mg sine theta is, we can copy from the previous one here. minus mg sin theta is unchanged. Look at this, we have written here mg sin theta is 75,000 sin theta, so it will remain as it is 75,000 sin theta equal to 1 to 500 12500 acceleration. Okay, then if we simplify more, it is going to be it is 400, so 400, half of 400 is 200, minus 200 minus 75,000 sin theta is equal to 12500 into acceleration. Now if we, it is 200 not 20, if we look at these quantities, every quantity is divisible by 5. Now if we isolate our 71 negative 75,000 sin theta is equal to, it is going to be 12500 acceleration, and from left side if we transpose it 3125 minus 200, so 2925. Okay, then sin theta, if we isolate, if we make sin theta as subject, negative symbol will dissolve. Everybody, it is 2925 minus 2925 minus 12500 alpha over 75,000. Okay, then I think each of the quantities are divisible by 250 or 25. Every quantity is divisible by, we may form this as equation. So sin theta is equal to, if every quantity is divided by 125, then it is going to be, sorry, we made a mistake. It's actually mg sin theta cannot be 7,500. It is actually 2,500. So 25,000, not 75,000. Instead of this 7, we will have to write here 2. This is actually 2. So this is also 2. Everywhere it will be transposed as 2. 2. This is also 2. Okay, now let me rectify them. So it is 2. Now each of the quantities is divisible by 25. If we divide by 25, it is going to be 25,000, means 1,000. So 1,000, and it is going to be 117 minus, if we divide by 25, it is 1 to, so 500. 500. Okay, this is our equation number 2. Now we will solve both the equations simultaneously. Let us see what are the equation. Both of them are sin theta. Hence, should I have a new page or I should continue? I think I should continue over here. So let's write from equation 1 and 2. From equation 1 and 2 and 2. So from equation 1 and 2, equation 1 was, this was equation 1, and 2 is this. So we can write 117 minus 500 over not 500, it is 500a, 500 and a. Okay, so my 500a over 1000 equal to, the other equation is 49 minus, let me write after zooming it out, 48 minus 75a, 40, sorry, 49 minus 75a over 750, 750. Or if we simplify, it is going to be, both of them are divisible by, one is 750, another one is 1000. So both of them are divisible by 250. By 250, if we divide this, it is going to be 4, then 117 minus 500 over, it is going to be 3, then 49 minus 75a. Now by doing cross multiplication, we will get 4 75s are, this is also a. 3 500s are negative 1500a, 1500a minus 351 equal to 449 is 296, isn't it? Or 196. 196. 196 minus 300a. 300a. So how many a's are there? 1500, and if we subtract, it is going to be negative 1200, negative 1200a, and it is for, if we add up 351 and 196, it is going to be, if we subtract 196 from 351, it is going to be negative 155, negative 155. Hence our a is going to be, if we divide 155 by 12, it is going to be 0.12 917. If we round it up to three significant figures, it is 0.129. Okay, that is acceleration meter per second. They have told us to find a. Let us go back to the question. What was our question? The question told find the acceleration value of a as well as theta. So we have got only a. A is, it is one of the answers. Okay, point one, this is, we have obtained value of a, one of the answers. Now for theta, we can apply this value at any of the equation. So let me find some space to apply this. I think we can use this place. We will write that a is equal to, a equal to what? Equal to 0.129, 0.12 as well as 9, when sine theta is equal to, sine theta, we are using the first equation, sine theta is equal to what? 49 minus 75 into 0.129. Let me write after zooming it out. 75 into 0.12 as well as 9 over, how much is the denominator? Denominator is going to be 750. It is 750, or theta is equal to, if we isolate theta, theta is equal to sine inverse of, if we calculate this, it is going to be, it is 0.05, 0.05243, 2 as well as 4, let me zoom it out, 243, sine inverse of 0.505243. 2, 4 as well as 3. Okay, then sign in using our calculator. We will find that our theta is equal to, hence our theta is equal to, theta is going to be 3.0 degree. 3.0 degree. That is what the answer to the final part of this question. So our acceleration is 0.129 and theta is 3 degree. Then let's see what the immediate next question say. The next question says on page number 9. Okay, it says the diagram shows the vertical cross section ABC of a rough water slide. The section AB is a straight line of length 5 meter inclined at an angle of theta to the horizontal, where sin theta is equal to zero point 0.8. The point B is 2.5 meter above the level of sea. A man of mass 80 kg modeled as a particle slides down the water slide starting from rest at A. The coefficient of friction between the man and the straight section of the water slide is 0.1. Find the speed of the man at B. So first we will have to first calculate the section AB. Since the slide is not smooth, rather rough, first of all we'll have to find the normal reaction. Okay, so before finding normal reaction we will have to complete the diagram. Let me complete the diagram. This is, suppose the person is over here. So this is our diagram. Then let's find normal reaction force. Our normal reaction force is going to be R plus, there is no upward force acting upward, there is no force acting upward, so it is 0. Downward force is what? Mg cos theta, Mg cos theta, or our R is going to be, mass of the person is 80 kg, acceleration due to gravity is 10, and cos theta. Okay, we will have to find cos theta also. Let us see what is written about theta. Sin theta is zero point 0.8. Sin theta is 0.8. That means we'll have to draw another triangle. If I draw over here using different ink, look at this. This is written that it's sin theta is 0.8. That means it is our vertical distance of perpendicular and 10 is our hypotenuse. So if 10 is our hypotenuse, then what will be our horizontal, I mean adjacent is going to be 6. Okay, because 8 square plus 6 square is equal to 10 square, applying Pythagorean theorem. So our cos is actually 10 over, it is 6 over 10, means 0.6, 0.6, 0.6. Hence our normal reaction is how much? 806. So it's 480. 480 Newton is our normal reaction. Okay. Then we will find the concept which is applicable over here. Look at this. Here the, so if we talk about the concepts which is to be the most appropriate concept for application for solution to this, actually both ways it can be solved, applying the motion law of Newton as well as energy equation. Work energy equation can also work, and I am going for work energy equation because in one step it will uh, produce the velocity, but if you apply resolving forces, then you will have to go for two steps, because in one step you will not get the velocity. You will have to get acceleration, then velocity will be obtained. Okay, so we are going to apply the concept of work energy equation. For work energy equation, we require the components of height as well as velocity, because In work energy equation, the major components are difference in final and initial velocities as well as difference between initial and final height. Initial velocity is 0. Look at this. He slided from rest, and final velocity is going to be obtained. But height, we require height. So for height, let us draw a triangle. Height is, suppose this is our triangle, it is height, okay, and angle is theta, angle is theta. Look at this, these, the length of hypotenuse is 5, so our height is going to be 5 sine theta, 5 sine theta. And sine theta is given, sine theta is actually zero point 0.8, okay, sine theta is given 0 0.8, so our height is going to be actually 4 meters, okay. So we do have both the initial and final heights as well as initial and final velocity. Final velocity is given, final velocity is to be obtained and initial velocity is 0. So let's apply the concept of the uh, work energy equation, okay. So for work energy equation, we know that work done by driving force minus work done by resistance force is equal to change in GPE plus change in kinetic energy. GPE stands for gravitational potential energy. Okay, as we know, the work energy equation is applicable for any external force applying on this. As there is no external force acting on the person, he himself is sliding down, so there will be no driving force at all. That means it is 0. Driving force is 0. If driving force is 0, now resistance force. For resistance, it is mu r. Work is equal to force into displacement. So force is, resistance force is mu r, because slide is rough, not smooth at all, into s. Into s is the displacement, okay. Then change in GP is actually mgh plus half mv squared, okay. Then if we simplify more, our mu is given, how much is our mu? Look, let's see the mu. Yes, mu is over here. Look, the water slide state the frictional, mu is frictional coefficient. Frictional coefficient is 0.1. So it is negative 0.1 into resistance to motion. We have already found normal reaction is 480 Newton. R is 480. Already we have found here 480. So let us write, and displacement is 5 meter. He traveled a distance of 5 meter. So it is going to be 0.1 into R is 480. 480 and displacement is 5 meter. Mass of the person was 80 kg. 80, and acceleration due to gravity is 10. Now h. Let's see what is the height. Actually, the person was moving downward. Height is decreasing. Initially it was 5 meter above, finally it is 0 in, if it is our reference. So final height is less than the initial height, that's why it is negative. Simply if someone moves downward, then height is negative. So we are going to write negative height has been 5 sine theta, means it was 4 sine theta was into 4, height was 4, plus half of m is actually how much? The mass of the person was 80 kg, okay, so half of 80 is 40. We can write here 40 and v square. Okay, final velocity, initial velocity was 0, that's why it is just final velocity is to be taken into consideration. So what is it going to give? If we multiply here, it is going to be 240, negative 240. From right side, if we bring this, it is going to be positive 3200, not 3200, it is going to be 80 into 10 into 4, that is 3200. 3200 is equal to 40 v square, so we can write 40 v square, 40 v square, or our v is going to be, if we subtract 240 from 32800, it is 2960, and due to square it is going to be square root. So 2960 over 40, 0 can be dissolved, so it is going to be 76. Hence our velocity is going to be square root over 70, square root over 74, sorry, 74, which is, if we convert it into decimal fraction, is going to be 8.60 meter per second square, meter per second. So we have obtained velocity. They have told us to find the speed of the person at B. So that is what the answer to solution to whole of this question. In one step we can do this, but if you apply the concept of the motion law of Newton, then you will have to uh, complete it in two steps. Let's move on to the next question. Question number B. Question number B says, it is given that there is no change in the speed of the man when passing through B, and his speed at C is 11 meter per second. C is at the bottom, actually, on the ground. Find the work done against the resistance force as the man moves from B to C. So already they have suggested that we will have to apply the work energy equation. Okay, so let us write work done by driving force minus work done by resistance force is equal to change in GPE plus change in KE, change in KE, or, so there is no driving force at all, hence work done by driving force is 0, because the man was sliding himself, no external force is moving him downward, minus work done by resistance force. It is to be obtained. Okay, work done against the resistance force is to be obtained, so let it remain unchanged. Resistance force is equal to change in GPE is mgh plus half of m v square. Okay, or work done by resistance force is equal to, mass of the person was what? Mass of the person was 80, and acceleration due to gravity is 10. Now h, look at this, how much is the h? H was, how much was the, we are talking about the lower part. Okay, so we are talking about this part. So here these portions, this part of the slide is 2.5 meter, here it is written 2.5 meter above the ground, but as he is moving downward, as the person is moving downward, so definitely height is negative, final height is 0. Remember, change in height means final height minus initial height. So final height is 0, initial height is 4, already not 4, 2.5, so it is going to be negative 2.5, negative 2.5 plus half of mass of the person is 80, and final velocity, they told that final velocity was 11 and initial was 72. Just we have calculated. So 11 square minus, so final velocity is already given 11, so 11 square minus initial velocity at B, we have got it square root over 74 on the previous page. Look at this, it was square root over 74, this one. So we can apply this exact value, minus square root over 74, then square. Okay, so final velocity minus initial velocity, or work done by resistance force, work done by resistance force negative work done by resistance force is equal to, here if we multiply it is going to be 2800, so it is negative 2000, and here then it is going to be 4, and 121 minus 74, here 121 minus 74, it is not 8, it is 80, it is 80 not 8, please don't get confused with this. So it is 40 into, from 121, if we subtracting 74 from 121, we will get 47, so it is 47. Hence, our work done by resistance force is going to be from 2000. If we subtract for this one, let me calculate. It is going to be 1 120 joule, 120 joule, and that's all about the answer. They have told us to find the work done by the person, work done against the resistance force of the man when he is at C. So our answer is 120 joule. So easily it can be solved applying the work energy equation. Let's move on to the immediate next question. Question number on the page number 10. Sorry, 11. It's question number 7 and last of all question. Let's see what it says. The question says a particle x moves in a straight line. The displacement of x from O at time t second after leaving O is s meter, where s is equal to zero point 0.3 t square plus 0 0.60 for 0 until 4 second. Okay, that means the expression for displacement is given and they have told us to find the velocity. Okay, so first let us write s is equal to, the expression is 0.3 t square plus 0.6 t, and we know that from displacement if we want to go back to velocity we'll have to integrate this. Let us do the we'll have to find the derivative of this. So let's differentiate this displacement ds over dt in terms of t, then it is going to be 0.6 t, 0.6 t plus 0.6 t raised to 0, that means zero point 0.6, or v is equal to 0.6 t plus zero point 0.6. They have told that t is equal to 4. Okay, t equal to 4 when our v is equal to, when v is equal to, what is it going to be? If t is 4, so 2.4, 2.4 plus 0.6, 0.6 equal to 3 meter per 3 meter per second. Yes, 3 meter per second when t was 4. And the next question says, for the second phase of this motion, For t is greater than 4, the acceleration of x at time t second after leaving O is a meter per second square, where a is 0.3 t raised to half. There is no change in the velocity of x at t equal to 4. The velocity of x at t equal to t is 14.2 meter per second. Find the value of t. Well, so first of all, let us write for t is greater than, this is for the second phase, greater than 4. Our acceleration is given. What is the acceleration given? Acceleration is given this, 0.3 t raised to half, means square root over t. Then from acceleration we will have to go back to velocity. How can we find the velocity from acceleration? Because they have told us to find the velocity is given here. Velocity is given, that's why we are turning the acceleration to velocity. So if we integrate acceleration, let us integrate acceleration in terms of t is equal to, so half plus 1 is 3 over 2, so it is going to be 2 over 3. So 0.3 into 2 over 3, and the exponent of t is going to increase by 1, so it is 3 over 2. Well, then if integrand of acceleration is actually velocity, so velocity is going to be 0.2 t raised to, here we forgot to use constant value, 2t raised to 3 over 2 plus constant value. Now let's see how much is the value of constant number. There is, they have told t is equal to 4 when velocity was what? Velocity we have obtained, since there is no change in the velocity when it is passing at 4th second, so velocity is 3 meter per second. So we can write t is equal to 4 when velocity is equal to 3 meter per second. From the previous question we can pick it up. After that, so velocity, the expression of velocity is 0.2 t raised to 3 over 2 plus c is equal to 3, and our time is actually 4. So zero point 0.2 into 4 raised to 3 over 2 plus c equal to 3. Hence our c is going to be 4 means 2 square. So 2 cube means 8, 1.6. So 3 minus 1.6 is actually 1.4. Our c is going to be 1.4. Hence our expression for velocity for the second phase is going to be 0.2 t 0.2 t raised to 3 over 2 plus 1.4. This is the expression of velocity for the second phase of the motion. Well, then let's see what did the question. The question has told us to find the value of t when t is, it has been provided that t is equal to, look at this, t is equal to 14.2 and our velocity is to be obtained. Okay, then t is to be obtained. Velocity is 14.2 and t is to be obtained. So let us write here on the right side, v is equal to, velocity is 14.2, 14.2, no, not velocity, we are going to find time. So let us write t equal to, uppercase t when v is equal to what? 14.2. So our velocity expression was what? Velocity expression of velocity is 0.2 t raised to 3/2 plus 1.4 is equal to 14.2. 14.2. Then if we substitute the value of t, it is going to be zero point 0.2, and this is t greater uppercase T 3/2, and if we subtract 14 from 142, it is 128, that means 12.8. 12.8. Or our t is going to be t raised to 3/2 equal to, by 2 if we divide 128, it is 64. Hence our t is going to be cubic root of this is 4. 4 cube means so it is 16. Okay, t is equal to 16. Answer to this question is our C, our value of t 16. When time was 16 second, then the velocity of the particle was 14.2. That's all about B. Then let's see what C says. It's on page number 12. Page number 12 says, find the total distance traveled by x between t equal to 0 and t equal to t. So, there are two phases actually. For the first phase, already displacement is given. Let me see 12, then 11, or third 11. At page 11, look at this. The expression for displacement for first 4 seconds is already given. This is the expression 0.3 t square plus 60. So let us find one after the other. So we will write, what will we write? We'll write, so for the first phase of the motion, let us write the duration for 0 until 4 seconds. Our s is equal to what? 0.3 t square. 0.3 t square plus 0.6 t. Okay, then it may be the first phase. Let us write the first one equal to, so t is 4. 0.3 into 4 square plus 0.6 into t. T is actually 4. Hence it is going to be 48, means 4.8. 4.8 and 2.4. So this is 7.2 meter. For the first 4 seconds, the particle traveled 7.2 meters. Then for second phase, for second phase means t is greater than, sorry, 4 until 16 second, because we have already found that greater t was 16 second. Okay, so for this one, for the second phase, we don't have an expression of displacement. We do have v. V is equal to, what was the expression we have used there? Look, our expression of velocity is this for the second phase. This is our basically 0.2 t raised to 3/2 plus 1.4. So we are going to just copy this. Let us copy over here. It is point 0.2 t, 0.2 t raised to how much? Raised to 3/2. 3/2 plus 1.4. This is velocity, but we are going to find the displacement, and if we integrate velocity in terms of t, and the limit is from 4 until 16. 4 until 16 is equal to, so if we integrate this, it is going to be 3 over 2. So 5 over 2 means 0.2 into 2 over 5. 2 over 5, we are doing integration, plus, sorry, t raised to, and the power of t is going to be 5 over 2, and the limit is from 4 until 16 second, plus 1.4 t. Okay, so let us write here t, and the limit is from 4 until 16. Hence it is going to be s2 second phase of the displacement. S2 is equal to, so 4, if we divide 4 by 5, it is 8, so going to be 0.08, and 16 raised to 5 over 2 minus 4 raised to 5 over 2 plus 1.4. 16 minus 4 is actually 12. 1.4 into 12, or S2 is equal to, let's say 16 raised to 5 over 2 minus 4 raised to 5 over 2 is actually 992. So 0.08 into 992. 992 plus, if we multiply 14 by 2, it's 168, means 116.8. Then if we do calculation, it is going to be S2, or S2 is equal to, the second phase is, it's going to 96.16. 96.16 meter. Now total distance, we can write now, total distance is equal to, total distance 96.16 in the second phase from 4th to 16 second, and in first 4 seconds it travels 7.2 meters. 7.2 meters. So total distance is going to be 103.4. 103.4 meter. That's all about this answer. So that's all about the whole of the solution paper, and let me show you each of the pages again. Page 2, then 3, after that 4, then there comes page number 5, 6, 7, 8, 9, as well as 10, 11, and the last page 12. So thank you for being with me, and if you think that any of the explanation or clarification benefited you in the least bit, then please pray to the Almighty Allah for beneficial knowledge for everybody. And if you think that this video is worthy of being subscribed, then please do so. Fi amanillah.